Welcome to Lesson 3, Measure. So after completing this lesson, you are going to be able to explain process analysis and documentation, describe probability, statistics, and statistical distributions, collect and summarize data, perform a measurement system analysis, and describe process and performance capability. So let's begin with topic 1. Process analysis and documentation. So there are some key objectives of the measure phase. One of them is to gather as much information as possible on your current process. The key tasks of the measure phase includes creating a detailed process map, gathering baseline data, and summarizing and analyzing the data. Process modeling refers to the visualization of proposed systems, layouts, or other changes in the process. Process modeling and simulation can determine the effectiveness or ineffectiveness of a new design or process, and can be done using process mapping and flowcharts. Process mapping refers to a workflow diagram which gives a clear understanding of the process or a series of parallel processes. Now, there are some features of process mapping. It's the first step in process improvement, and it gives and provides a systematic way of recording, and it gives a wider perspective of the problem and the opportunity. Now, process mapping can be done by using flowcharts, written procedures, or detailed work instructions. A flowchart is just a pictorial representation of all the steps of a process in consecutive order. Now, there are some commonly used symbols in the flowchart. One of them is the square. That is equal to represent the process. Then you have your arrows, which are the direction of the flow from one step to another. Then you have the diamond, which is our decision-making symbol. Then you would have a D, or filled in D, which would stand for a delay or possibly a wait. Your circle or your oval is the beginning or the end of the flow or of the flow chart. A parallelogram would be the input or an output, and then you might have a little rectangle with a little squiggly line at the bottom, which would be like a document. Now, there are no flowchart police, but the generalized ones to really recognize would be the square, the diamond, and the oval. So here is an example of a flowchart, which shows the process in software development. So it begins at the start, and then the next step in that process is design. And then the next step is coding, and then the next step is testing. Now we come to that diamond, which is our decision-making step. And decisions are mutually exclusive. So they're yes or they're no, or they're right or they're wrong, or they're A or they're B. Now, if there are any errors, because that's what the diamond is asking, it's asking if there's any errors, and the answer is no, then the process ends. If the answer is yes, and there are errors within our software, then it's going to go to another step, in this case, another decision point, where then it's asking us, is the error a design error? And if it's yes, then it's going to go all the way back to the beginning to our design step. If the answer is no, then it's going to go to the coding step. Now, a written procedure is a step-by-step guide to direct the reader through a task. Written procedures can be used when the process of a routine task is lengthy and complex, and when you want to know what is going on during product or process development phases. Now, with written procedures, they're going to help in avoiding mistakes while ensuring consistency. They're going to streamline processes and save us time. They're going to improve our quality, and they're very simple to use and to understand. Now, some of the important features of work instructions would be that they define how one or more activities in a process should be written in detail, using technology or other resources. And they also provide step-by-step details for a sequence of activities that are organized in a logical format so that an employee can follow it easily and independently. Now, if you're dealing with a less detailed process, I would use a flowchart, and for a detailed process, more than likely work instructions. So here is a great example of a work instruction for a shipping electronic instrument. Take a couple minutes to review the work instructions. Any improvement of a process has a few prerequisites. The first one is that to improve a process, the key process output variable and the key process input variable should first be measured. Now, metrics for key process variables would include anything from the percent of defectives to operational costs. Maybe it's elapsed time, backlog quantity, or maybe it's some sort of documentation error. The process owners are the best source for initial identification of what those critical variables are. Next, we have to find the relationship between the variables that are depicted using tools that we've discussed, such as a SIPOC and a cause and effect matrix. And then the process input variables results are then compared to determine which input variables have the greatest effect on our output variables. That concludes topic 1 in measure. In topic 2, we'll come back to probability and statistics.